When you first took science class in school, you probably learned the basic steps of a scientific investigation. You've likely heard of words like hypothesis, experiment, and observation. You may have even memorized a prescribed set of steps. The scientific method is a set of procedures that scientists follow in order to gain knowledge about the world. However, the steps involved in the scientific method vary widely among the different scientific disciplines. Chemists follow the method a bit differently than psychologists. Geologists and botanists have their own unique methods. So is there really one scientific method that encompasses all of science? To find out, we'll need to learn more about the scientific process. There are 6 key steps that tend to characterize the scientific method. The first step is the question. This is the part where a scientist proposes the problem that he wants to solve. A well-conceived question usually leads to a hypothesis, a potential answer to the question at hand. Sometimes hypotheses look more like predictions. The scientist predicts what the outcome will be when he tests his hypothesis. The scientist's test is also called the experiment. Experiments are ordered investigations that are intended to prove or disprove a hypothesis. Important data comes from performing an experiment. The scientist has to make observations of the results that he gets from the experiment. An observation is a statement of knowledge gained through the senses or through the use of scientific equipment. Observations are crucial for collecting data. Once the results are in, the scientist must begin his analysis. Data analysis involves comparing the results of the experiment to the prediction posed by the hypothesis. Based on the observations he made, the scientist has to determine whether his hypothesis was correct. Then he sums up his findings with a conclusion. The conclusion of a scientific process is a statement of whether the original hypothesis was supported or refuted by the observations gathered. The scientific method usually employs all 6 of the steps I mentioned, but the steps don't always occur in the same order. Real scientists may go back and repeat steps many times before they come to any conclusions. It's actually better to use the word elements to describe the steps, since the first step, question, does not always come first. Sometimes, for example, it's an observation that came first and spawned the initial question. Likewise, observations that are made during an experiment can inspire more questions that scientists have to answer. The scientific method is much more fluid than you might think. Let me show you how the steps can feed back and branch out from one another with an example from my own experience. Last weekend, I had a minor ordeal with my internet connection at home. I had started up my laptop and I was frustrated to find that I couldn't get on the internet. I made the observation that my laptop wasn't receiving an internet connection. I asked myself a question. Is something wrong with the internet itself, or was it just my laptop? One way to begin answering this question was to check the connection on the desktop computer. Quickly, I formed a hypothesis. If the internet isn't working on the desktop either, then the problem is beyond my laptop computer. The experiment I performed was to check the desktop's connection, and my resulting observation was that the internet didn't work there. So, by analyzing the evidence, I was able to form my first conclusion. Nothing is wrong with my laptop, and something is wrong with the internet connection. Now, this conclusion answered my first question, but it still didn't get my internet to work, so I had to pose another question. Where exactly was the problem occurring in the chain of internet devices? Was it the cord between the modem and the router? The cord between the router and my computer? Or was the problem in the router itself? I had to form another hypothesis. If both my internet cords are properly plugged in, then there must be a problem with the router. My experiment was to check both cords and the router. My observation was that both cords were plugged in and that the router was off. I analyzed the evidence and my conclusion was that I couldn't connect to the internet because my router